Okay, everybody, let's get started. Welcome to the CA Technologies Layer 7 webinar, Drones, Phones, and Pwns, the Promise and Dangers of IoT APIs. My name is Jamie Ryan. I am Senior Director of Product Management and Strategy at CA Technologies in the Security Business Unit. Prior to that, I was at Layer 7, so I came over as part of the acquisition. So I gave a similar talk to this at a conference last month, and we had people swarming our booth for the rest of the afternoon. So we decided to do kind of an encore presentation that really seemed to resonate with people. So if you have any questions during today's talk along the way, feel free to put them in the chat window in the sidebar, and we'll get to them at the QA at the end. So I'm guessing about half of you are here because of the title, so I guess it deserves a bit of explanation. When I was trying to come up with the title for the talk, I knew I wanted to talk about drones. I knew I wanted to talk about phones, so I asked my wife for a good rhyme. She's a high school English teacher, so I thought she'd come up with something profound. Instead, she immediately came up with Pwns, mostly as a joke. So I decided to accept the challenge. I said, that's great. I'll talk about how insecurity and the storage and transport of personal identity information and other data can put us at risk of loss of privacy, fraud, and worse. So as soon as I started talking tech, she fell asleep, but I figured it would be a pretty good topic for a more technical crowd. So welcome. So I want to talk about drones, I do want to talk about phones, and I want to talk about IoT and the potential threats and vulnerabilities of each of those. And because we're an API management company, I also want to talk about APIs, because APIs are really the glue that holds the IoT world together and turns dumb things into smart things. So we'll talk more about that later. But more than anything, I really want to keep this talk personal. Real benefits of these technologies, real issues, real things you as an individual deal with every day. And if you can relate and see how these connections impact your daily life, hopefully it'll be easier to see how they impact your enterprise as well. So let's get started with some real-world scenarios. We'll talk about the technology behind them, and we'll see if we can have a little fun with this topic. So what does the future hold? We're going to talk about the future, but in many ways the future is already here. We're starting to see some great applications of technology like drones to solve real-world problems. So I'll show you some examples, and then we'll talk about kind of what's next, what the future holds. So when I say drones, most people still think about UAVs, these unmanned aerial vehicles flying high over Afghanistan, Iraq, Syria, keeping an eye on things for the CIA or the Air Force or the DoD. And while those certainly aren't going anywhere and are still in use, there's also a couple new generations of drones that are for commercial or even personal use. I mentioned my wife is a high school teacher. When I gave this talk previously, I introduced it with a video taken by one of her colleagues, the broadcasting advisor at her high school. And so they bought a drone to use at football games and other school events. So all of the pictures you'll see here are stills from that video, from a test run that he did last year in Cape Cod. So I didn't want to overwhelm everybody's bandwidth while playing the gorgeous full HD video over WebEx, but I think you can still get a feel for how detailed and how kind of true to life the resulting feed can be. So the model that took this video cost about $500. Of course, they range in price, $200, $1,000. Super affordable, especially for a technology that's still kind of a relatively niche market. And it's not necessarily just video that something like this can send back. So it can do telemetry, it can do sensor readings, it could take information extracted from artificial vision technologies to figure out exactly what you're looking at in any given picture, facial recognition, anything's possible really. And though we're not talking about the privacy implications yet, we're going to get to some of the scary stuff later. If I put some creepy music over these shots of old ladies and people playing on the beach, you can start to imagine some pretty scary scenarios. The low altitude flying that these things can do is pretty impressive. The point is that they're everywhere, and there's a lot of potential, even in these personal use cases. So let me just show you all of those stills were from a video taken by this tiny little package. So now just imagine what we can do when we scale this up for commercial purposes. So what can we accomplish? Well, Google recently purchased Titan Aerospace, and this is one of the drones that they're starting to build. So in addition to Project Loon, which Google's already working on, which is a series of balloons, high elevation, basically weather balloons, that they use to distribute satellite internet, now they've added these drones. So these drones can fly at over 60,000 feet, so twice as high as the flight you took last week or last month. And they can stay aloft for up to 5 years. So they don't have to come back down for 5 years because they're solar powered. And when I say scaled up, I really do mean scaled up. So the wings on this thing are longer than a Boeing 757. So if you can imagine all these massive solar-powered drones flying over our heads at 60,000 feet up for 5 years at a time. It's pretty impressive when you think what we might be able to accomplish with those. But what can we accomplish? Even without these drones, we can do a lot. And so this is where I want to start to talk about phones as well. This is a screen capture from my phone from the last time I was in New York. You can see we already get information about traffic speeds, so all the red versus green versus yellow. We already get, and that's coming from other phones in the area, other Android phones. We get reports of traffic incidents. So this is coming from the Waze API. Google bought Waze last year and has already integrated that API into Google Maps. If my taxi driver hadn't had this exact same view on his phone in the front seat, he might not have known which bridge to take to go over and get me to Newark, so I didn't miss my plane. So with additional data from drones, we could essentially have a real-time view of traffic from above and see these accidents as they occur, be able to pick out exactly when the accidents happen, and we'd be able to report that information to police and paramedic crews automatically, which brings me to some of these use cases around emergency services. So this was also last month, as I was being evacuated from my home in northern San Diego. I said I was going to keep this personal, and I am. So as you can see, there's a significant fire about a mile away, just over the hill, but we're stuck in a line of unmoving cars. It stretches all the way back there, trying to get out with no way to get more information. It gets busy during wildfire season, so there were 8 other fires in San Diego that day, so there was no air coverage left for us. So really, we're literally flying blind. The helicopters and tanker planes, they're limited. They cost millions to run. But a lower-cost alternative, like a drone that's constantly up there, or even a little micro-drone, could really have helped in this situation. Why couldn't we see exactly what was happening on the other side of that hill? This is 2 days later, still evacuated. We had to watch on TV as they showed the burned area, all this red stuff, drawn by hand on a Google map by some dude in the back of the NBC newsroom. Why can't I get a real-time overhead view of the area? Why can't I see if my house, which is literally right there on the edge, was still intact? It seems simple. It seems like something we should be able to do now. So continuing the discussion of phones, we're still talking about Google. While I'm a fan, it's a coincidence rather than intended. They just happen to be pretty far ahead in terms of integrated solutions for gathering data from millions of people, because they're in every Android phone, and using it in a manner that helps. So this is another little innocuous thing that's already happening in Google now. I just noticed it recently and thought it was cool. I parked at a mall in Massachusetts. This was waiting for me on my phone when I came out. So it recognizes that you've stopped, headed into a mall, records where your car is for when you come out without any human intervention. I know there are apps for this, but you generally have to do that yourself. You have to tell it that you're parked and have it remember. This is all just automatic. you'll start to notice a theme here. So location is really important to many of these use cases. It's an incredibly important part of many IoT scenarios. So think fitness, when you're out running and it's tracking your mileage. Think supply chain tracking. Think inventory management, or where a particular piece of inventory is, whether it's in the store, whether it's on its way, whether it's in the back room, whether it's on the floor, whether it's headed out under somebody's shirt or in somebody's backpack. And once again, Google is collecting everything it can. So everywhere your Android phone or iOS phone running Google Now checks the GPS, you get a little point on the map. And then you take all these points and plot them over time, and you can see, you can basically walk through your history. So this was a month of my life back in late April to May, and you can see my trips to Central California, to New York, to Boston. So personally, I like this, as long as it's only me and Google that can access it. But the creepy factor can definitely set in if you felt differently. It's actually opt out, so you can opt out of this. I haven't chosen to do that yet. And then detail is also important. So if you can figure out exactly where somebody is, you can send them contextual advertising. You can help them get from door to door. So on the left, you can see kind of a week of driving around my hometown in San Diego. On the right, you can see that trip I took to New York. You can see me coming in from JFK, doing all the various meetings I had in Manhattan, and then heading out over that bridge to Newark on the left. So let's take a step back. We've talked about drones. We've talked about phones. What we're really talking about is the Internet of Things. So let's start with the definition. I tend to define IoT pretty broadly, consisting of basically everything connected to the Internet with an IP address or connected to an IoT hub. That's another connected device. So that would be anything from a single sensor to a laptop to analytical underwear, which, yes, they exist, to a connected car. Like I said, it's a pretty broad definition. Perhaps you've seen this visualization of the Internet before. It gives some idea of the grand scale of things out there, things with a capital T. But let's get a little closer, a little more personal. Here, the close-up, so you can see some IP addresses, some indication of which devices are connected to which others, how they become a network. And any one of these things, any one of these IP addresses can be a thing, a capital T thing, or a hub for things. And I'll show you what I mean in a bit. Here's a more democratic definition of IoT. So I took 8 or 9 articles about IoT, some popular recent articles, and threw the entire text into a word cloud generator. So essentially, this is the consensus across all of those articles about IoT and various use cases. So if you want to be more specific about things that are usually discussed, you can get some idea here. There's sensors, and you see machines, devices. Obviously, connectivity is a part of it, and data and information is another huge part. So let's see some examples. I like to categorize things, capital T things, into 2 categories. There's dumb things and there's smart things. So first I want to talk about dumb things. These are all dumb things that either collect data or they do something. So that means they're either sensors or they're actuators. They often work in conjunction, so sometimes they're even in the same device. But it's often useful to distinguish between kind of the data collection piece and the actual implementation of action or interaction. So here are some examples in a few different areas. So quantify itself. Collecting data, you're tracking your exercise, you're tracking your calories consumed, it's paying attention to your sleeping habits, but then you want to do something about it. So it's actually spitting out customized workouts, or social running routes, sleep suggestions. Hey, it's time to go to sleep. surveillance. Again, you have data collection, so you have capturing images, capturing video, and this can be home, retail, gambling. So Las Vegas is pretty far ahead when it comes to this type of technology, but there are both personal and commercial applications. And then you want to do something. So there are new doors, door locks, that you can unlock based on Bluetooth or NFC proximity. So if you have your phone in your pocket and you're right outside your door, you can unlock it, but nobody else can. Agriculture. So you can track conditions in the soil, in the air, in the actual meat or milk. You can track your supply chain, and then you want to do something about it. So you can actually increase or decrease that irrigation. All those can be controlled by actuators. You can change your feed. You can spray pesticides. So all this can be automated as well. Smart parking, obviously you need to know what's going on first. You need to know which cars are in which spots. If you can plot those empty parking spaces, that's great. And then you also want to provide connected meters. So you want to email the driver when it's time to pay for more time, so they don't have to go all the way back out to their car and stuff some work orders in. I mentioned those analytical underwear earlier, and that's a real thing. So you can actually get sensors in underwear, and as gross as it sounds, you can actually tell a lot about a person's health by what you can record from the trace elements that end up in your underwear. Well, let's not get too detailed there. But pacemakers, and then you can do things about it. You can remind patients to take medication. You can notify medical personnel when it senses something happening. So again, these are connected. The sensors are connected to the actual things that do something. Retail inventory, tracking items in store, and then actually placing orders or alerting staff if there's a problem. Energy use, identify appliances that are using a little too much energy, collect meter readings, but then you also want to be able to turn on the lights, manage your AC. So Nest is a pretty popular IoT example right about now. It's basically the connected thermostat. So another personal example, when I was out of my home for the fires, when we were evacuated, my neighbor emailed a picture of the sheriff that had come to his door to make sure we were all out. So he had a front door surveillance camera that emailed him anytime somebody came to his door after dark. And so we've got a nice little picture of the sheriff checking on our houses and making sure they're okay while we were out of our houses. So these are just a few. Here's one more. So supply chain isn't just about freight being hauled around on railroad cars anymore. It even determines how milk gets from the cow's teat to the refrigerator. So the cows themselves are tracked as they're wandering around the field. There's biological sensors in the milkers, so as the milk's being extracted, it's actually testing that milk right there. There are temperature sensors throughout the pasteurization process, and then after the pasteurization process, once it gets cooled again. So that chilled milk gets put on a truck. It has to stay below a certain temperature all the way to its destination. So there are temperature sensors in the truck, in the case of the milk. The driver and the truck themselves are tracked and the route's optimized. So maybe you've heard that all UPS drivers are only supposed to turn right, and somehow they've decided that's a cost savings. The same thing happens with any sort of long haul freight. They tend to optimize the way drivers get places. And then after delivery, you have to certify where the milk came from, how old is it. You have to demonstrate that temperature consistency to the FDA, so there might be temperature readings that you need to save and then demonstrate for regulatory purposes. And then the grocery store tracks their inventory. They have to pull it from the shelves if it's too old. And then finally it gets purchased and put into your fridge. So that supply chain, it's pretty long, and IoT is involved at every step of the process. So speaking of fridges, I promised not to talk about the connected fridge concept. There are a million great IoT examples For some reason, people insist on going back to that one. I just think it's lazy. But I promise not to talk anymore about that. So everything's going through this evolution of connectivity. Industries are embracing IoT, and really dumb things, completely disconnected, lowercase t things, are being replaced by connected things, capital T. So Nike is transforming into digital fitness. Connected cars are all the rage. Smart meters have been rolling out for years, actually. And the big players are all investing billions in the connected home. And once basic inroads into the quantified self are moving toward the inclusion of medically necessary wearables, remote medicine, and even digital supermarkets. So everything is going through this evolution. And so this is where we come to smart things. We've talked about dumb things, now there's the smart things. Smart things bridge the gap. So between dumb things, they allow for human interaction and decision making. So it's not enough to just record something. If there's no usage of that data, then you don't really get any value out of it. So this is the place where you create and enforce policy. Perhaps you've heard of if this, then that. So if this particular sensor reading is over a certain number, do this. Start some other process. Implement some other policy. Often these smart things involve a portal or a UI into the world of data, let you access this data in a graphical way that means something to you. And most of the time, these are app-based. So we talk a lot about apps, and we'll talk more about apps, but most of these things are app-based. So we're talking apps run on laptops, desktops, tablets, phones, even smartwatches. So these smart things are really where we kind of get to the next level. So we saw earlier that the network is complicated, and even when you zoom in, the network's still complicated. When you get down to the nitty-gritty of IoT, it's complicated as well. So you can see sensors and actuators, the dumb things. You can see collection points, the various domains involved, what's connected to what. So I don't want to get too detailed here because it's entirely dependent on the use case, on the implementation style, on the protocols you've chosen. But we'd be happy to talk to you about your individual topology if you have questions at this level. Well, rest assured, there are lots of frameworks to deal with this world. There are lots of protocols to implement and to secure. There are lots of SDKs to manage and control things. So Arduino, even Android, embedded sensors, embedded devices. There's SDKs to manage that portion of it. But when it comes to the human interaction, to enabling your consumers to manage their fitness gear or to interact with their medical devices or to learn more about the weather or the neighborhood around them, that's where APIs come into play. So when your employees can manage their inventory and ordering and supply chain from a single dashboard, or use readings from a customer's smart meter to provide better customer service, or place orders while in the field, that's where APIs are the key. When you get into your car and start playing the Pandora stream that was on when you left the house, that's where APIs are key. So APIs are really fundamental to IoT. You've collected all this data. How do you get it onto multiple platforms? How do you build a great user experience on a phone, on a watch, on your car? How do you differentiate between yourself and your competitors? You provide a great API. So these APIs are what get us to the smart things, the apps, the phone interfaces, the smartwatches. These APIs are what actually provide differentiation between the dumb things that nobody ever sees and the smart things that people actually interact with. So we've talked about drones, we've talked about phones, we've talked about IoT, we've talked about APIs. Now we get to the part where I try to scare you just a little. So to start with, we're going to circle back to drones. So these are all relatively recent news stories, just to give you an idea of all this data that's being transferred around, all these connected things, where there might be some vulnerabilities. So first, we've got some data exposure. So the feeds from our drones are broadcast basically in the clear and can be viewed with a $26 piece of shareware. So anybody can go download this $26 piece of shareware and start to view the actual broadcast from these drone feeds. And yes, this is military. So it might not be personal, but you'd think data privacy would be even better in these military applications. So we have to worry about data, including video, being collected by drones. But what's the worst that can happen? They see what we're saying. They maybe shoot down a drone based on what the location is. Well, no, it's more serious than that. The worst is that they could, in theory, kill American pilots. So what the Air Force did, I've been told we've lost audio. Oh, okay, we're back. So let's see, how far back should I go? Let me just go back to the start of this slide. So we talked about the video from Predator drones. Now the same video is on just about every military plane because they wanted the same sort of immediate video feed to see what's going on with fighter jets flying over contested areas. Most of us don't have drones or fighter jets, though more and more people are buying drones. But what do we have? We have cars. So this is about weaknesses in car computer systems. Hackers can basically take over your car. They can slam on the brakes at freeway speeds. They can jerk the steering wheel. They can shut down the engine, all remotely controlled from a laptop. So while you might not have a drone or a fighter jet, there's a pretty good chance that you have a car. And how many people have an Xbox One? Well, it sold 8 million units in the first 2 months on sale. I'm sure quite a few more have them now. They're always on. So that Connect that came with your Xbox One, unless you bought it in the last month without it, are always on. They're always watching, and they can make judgments about you based on your nonverbal behavior. So even if it's not listening, it looks at every move you make and can continue to observe that and make judgments. Okay, how many people have Facebook? So Facebook has a new feature. It's optional, but it basically turns on the microphone to figure out what you're doing. So you start to share a post about what you're up to. It immediately turns on the microphone. It listens to the ambient noise around you. It figures out what you're watching, what you're listening to, where you're traveling, what you're reading. And of course, when Facebook collects data, the whole point is to share your personal information, both on your social network to your friends, but also to advertisers. So all that information is floating out there based on what it heard every time you post a status update using this optional feature. So it's creeping a few people out. And of course, I don't even have to ask who has a phone. I'm guessing everybody on here has a smartphone, and though there's plenty of security, I'm sure if you're listening to our webinars, you've been around the block and you've looked at MDM and you've looked at some of these security technologies for phones. Well, all that is kind of at a higher level. So what I'm talking about is the broadband chip, or the baseband chip. So there's only a few manufacturers. Every phone has this baseband chip. It actually does the interaction with the cell tower, does the really low-level voice communication, and there's only a few manufacturers: Broadcom, Qualcomm, Ericsson, Infineon, that are shared amongst all of the vendors. It's shared infrastructure. It's below MDM if you got mobile device management on your phone, and it's hackable. So you can actually turn your phone off, and if the baseband chip has been hacked, it can make it so it's not really off. So it appears to be off, but it's actually on and listening. So the only way people can tell is that their phone is still warm while it's off, while it's reportedly off. So that's a little scary. Obviously, everybody's got their own address books. The NSA is collecting these address books, so every time you start to type a user into Gmail to send an email, and Gmail sends back a selection of potential matches. So you start to type the first couple letters, it suggests the matches. All that stuff goes back and forth and is being collected by the NSA. So they collected over 1 million address books in a single day. And that's from Yahoo, Hotmail, Facebook, Gmail, 250 million contacts a year. So let's just hope you don't have any friends named Osama. But it's not just the NSA either. So this is a recent discovery about other law enforcement agencies. They can actually set up fake cell towers called stingrays. The cell phone connects to the stingray instead of the tower. The stingray forwards the signal to the real tower, but not until it gathers all of the incoming and outgoing call data, text data, the numbers you've dialed, the location, so basically where you are. And in theory, this is all done in the pursuit of criminals. But it's not just law enforcement either. So we talked about Facebook. They're not alone. Specifically, this article is about a few different apps, one called Color. So it takes the ambient noise and ambient light in the room to figure out who's around you. So it actually listens for voices and creates a local social network. So this person is in the room with you, this person is in the next room, and it does all that based on just the ambient noise that it records from your microphone. Shopkick. So if you go to, I forget which stores were involved, Macy's maybe, they can actually broadcast an inaudible sound in the store. Shopkick, as an app, recognizes, turns on your microphone, listens to the ambient noise, hears that inaudible sound, because your phone can hear it and you can't, and recognizes that you're in that particular store, and then can show you ads for that store, coupons for that store, show you things related to where you are. And then the third one is called Into Now. So it turns on your microphone, it listens to the TV you're watching, and it figures out what point you're at in a TV show to do, so you can do social networking based on where you are, so you don't get spoilers from later in the show or give away too much to people that aren't to the same point. So all of these have very practical uses, and they make sense if you're looking for one of those things, but they can also determine your gender, the gender of people you talk to, your age and the age of people you talk to approximately, what time you go to bed, what time you wake up, what you watch on TV, what you listen to on the radio, how much of your time you spend alone or with others, whether you live in a big city or a small town, what form of transportation you use. So there's a lot of information that you're putting out there just by installing these apps. So again, I'm not trying to scare you, but at this point, your car, your phone, your gaming platform, and your apps are all potentially working against you. So what are the concerns, and what can we do about it? So I'm trying to get you to stop using any of these things, but awareness is always useful. What questions do we have to ask ourselves moving forward? And the first is identity. So if you lose control of your identity, there's massive implications for just about everything in your life. How do we retain that control? How do we authenticate ourselves? So what standards are being used? Are they secure? What biometrics are being used? Are they secure? Does the Touch ID sensor on the iPhone 5S or the fingerprint reader on the Galaxy S5, do they really work as intended? Are they really secure? How do we delegate information about ourselves when necessary? So custody, identity custody is also a big concern. Who has our information? What information do they have? What do they actually need to perform the task that you count on them for? And then who do we trust and why? Do we trust Google because of a "Don't Be Evil" slogan? Do we not trust Facebook because they've botched privacy updates again and again? Can we trust anybody if the government's going to snoop anyway? So these are all just questions that you have to ask yourself. And then privacy. So how does information get from one place to another? Are those pathways secure? What role do we play in that? So these are the challenges that Layer 7 and CA technologies as a whole are really trying to solve. These challenges around identity, privacy, security, identity custody. So before we go any further, I'll tell you right now, we're not going to solve all your problems. So some of the solution is social, some of the solution is awareness. So be aware of who has your information and why. So again, to add a personal touch, this is my actual Google account permissions for every device and app that has access to my Google account. If you click on one, you can actually see what access it has, so you can tell exactly what information that they're getting about you. So it's always useful to check on things like this occasionally. Make sure you recognize all the devices. Make sure you recognize all of the third parties that you're giving your information to. This one is the Facebook app settings. So in the Facebook privacy FAQ, which is something I just read for fun, there's a list of 70 categories of data that they collect. Big categories, like about me. So that's a bunch of data about education, relationships, etc. There's also scary categories, like hidden from news feeds or removed friends. Nothing ever really goes away. It's all information that they collect and, in theory, record. So you might want to take a moment to sit back, think about all of the companies you do business with, how much information they have about you. Now think about your company that you work for. How much information do you have about your customers? How much information do you have about your employees? And are you doing whatever it takes to safeguard that information, to be a good corporate citizen? So here's the most personal example of all. I decided to do a little exercise on my own, and I graphed my connections with entities that have identity information about me. So I probably could have added about 30 more, but I think I came up with about 50, and these are the primaries that I use routinely, every few days, every couple of weeks for travel. So I've grouped them into categories. So here's the social networks. Across the top, you have the travel companies. Over here on the right, you have shopping and finance. You've got delivery companies that know what you're buying from who and where it's going, where you live. Down on the bottom right, all your utilities, so they know who you're calling and what TV you're watching. Down on the bottom left, we've got healthcare, we've got education, and then on the bottom, we've got all the various devices. So all the devices you use to connect to all of these various entities. All these connections are first level. They're very much 1 degree of separation. They're connections from you to them. Now think about how this graph expands as soon as you go out a single level and start adding your connections to other individuals on social media or to other shoppers at the same stores, to other patrons at the same bank. Think about the attack surface presented by each of those entities. So just be aware of who has what info about you and how much you want them to have. This is a pretty useful exercise for myself. So what steps do we take in this new interconnected world? So this goes beyond just informing yourself about who has your information. It goes beyond the cultural and legal hurdles around privacy in our country. At some point, it gets down to a discussion of technology, and that's where Layer 7 comes in. At Layer 7 and CA, we worry about very real technology issues, how to authenticate you, how to build the trust relationship between the parties around you, how to get your data where it needs to go. And in your role at your enterprise, we worry about how to manage your corporate identities with employees and consumers, how to secure the interfaces where partners and apps can access your data, those APIs, those external services, how to open up more channels for your business, how to help you build the smartest things, the capital T things around. And we're always planning ahead. So in a few years, hopefully you'll have less to worry about because we'll be able to move to a more brokered identity model where you decide who should get access to your information and for what reasons. So when you go to buy a new camera and Best Buy needs a credit card number, instead of storing it themselves, they'll be able to get a one-time use number from MasterCard. When it comes time to ship you that camera, they just get it to FedEx, and then FedEx can worry about your address. So that's a future state, but what's going on to enable this revolution in identity and data management? APIs. So APIs are central to the modern open enterprise. You have all these new consumers, mobile devices, partners, cloud applications, IoT, and the enterprise is transforming internally as well. Everything's moving to software, so you can manage your infrastructure. You can expose your data and applications to external consumers, all using APIs. But this is opening up even more, not less. So how do we manage this new open infrastructure? With an enterprise-class API management solution. So you want to be able to alleviate the fears of your customers, your partners, your employees, to manage their identities and their data with their respective deserves, to enable those apps, those smart devices, those IoT use cases, without having to worry about security at every step. And that's where we come in. So we've got the gateways for the runtime enforcement of policy, security, integration, SLA management, identity brokering, API exposure. We have a developer portal for management of the business side of APIs, so enabling your developer community to discover and use your services to build smart things and smart apps while maintaining control of the relationship between you and your developers. And we have enablement tools for mobile app developers. So we've put all these security barriers in place, but you want to remove that difficulty of coding against all the various standards that you want in place, but that you don't want to have to build from the ground up, like OAuth and OpenID Connect and certificate management for mutual SSL, that sort of thing. So we can worry about that so that you don't have to. And we focus these products around 4 key areas of API management. So managing the interface, the actual APIs that you're exposing, what happens to them at runtime, how are we going to optimize those, how are we going to compose multiple services into one, how are we going to transform to connect to your backends, how are we going to integrate things like location and other pieces of context that make your app smarter than everybody else's, smarter than your competitors. We focus on identity management. So who's the end user using this? Who is the developer that created this app? What's their API key? How often have they made calls? What sort of usage am I getting based on user, based on org, based on any other bit of identity? What pieces of data is a particular user given access to? How can I broker from OAuth and OpenID Connect on the front end to my existing identity management services on the back end, my SiteMinder, my Oracle Access Manager, my Novell, my LDAP, my Active Directory. Operations management. So obviously this needs to be enterprise class. So you need to be able to integrate with your systems. You need to be able to generate reports. You need to be able to track the health of your infrastructure. You need to be able to move from dev to test to prod in a simple fashion and a robust fashion. And then developer management. What plans are out there that developers can use to access your APIs? Can they test those APIs interactively in your documentation? Can you get information about which organizations are providing you the most value, which have the most popular applications that they've built using your APIs? Can you provide support to those developers through forums and through notifications and interactions? So this is what we do, and this is where you can make your dumb things smart things and really transform your business. Okay, any questions? Let's see. Why are APIs positioned as relevant for human interaction and not M2M? So it's a good question. It seems to me that APIs are fundamental for human interaction and machine-to-machine. That's absolutely true. The challenge when you're talking machine-to-machine is because it's relatively new, you're talking about 1,000 different specifications and probably 10 different protocols and lots of proprietary ways that that people have built this. So you're never doing anything the same way twice. And so it's very difficult to talk about those APIs at that level. So I mentioned all the frameworks and SDKs and protocols. There are toolkits around each of those, and those are great for making sure that sensors can connect to hubs and smart meters can talk to a collection point. And but it's at the point where you need to take that data that's been collected and get it back into your CRM system or your other internal systems, your asset tracking system. That's when the kind of more generic, more standards-based HTTP web APIs come into play. And certainly we are talking about other IoT protocols as well. We support XMPP now. There are others on the roadmap. But yeah, there aren't as many standards across the board for those M2M communications as there should be. And the follow-up question, doesn't that make the case for APIs stronger? Absolutely. And if you want to talk about implementing all of those lower-level connections using more broader standards, let's put it that way, we'd be happy to have that conversation with you. Okay, one of my consistent questions is, what is an API? Often seems that API is defined essentially as the code and specifications of the programs, database resources, et cetera, of a corporation. That's a great question, and we've got lots of material about kind of the way the term has transformed over the years. Originally, you could think of an API as the Java API, basically the specification that you're going to use for a programming language that was going to be run and executed locally on a machine. So what those functions look like, what parameters they took, et cetera. And so you would have a compiler and actually write code against that. When we talk about APIs now, we're talking about web APIs, which is distributed connections between servers, between remote machines where they can communicate with each other using standards, open standards that have already been around for years for web interactions. So generally HTTP as a transport protocol and XML or JSON most often as a message format. And so when you publish an API that allows this interaction, you're publishing, okay, this is the format of message that I'm expecting, and this is the HTTP URL that I'm expecting it on, and then based on that URL or based on something you've posted within a message, based on the HTTP method, so get, post, put, delete. You're going to perform some action, retrieve some data, update some record. So those are the APIs that we're talking about. Okay. Oh, that's a long question. Okay. Why are APIs positioned as relevant for human interaction? Oh, wait, no. Same one. Assume that Evernote creates an app called Evernote that is note-taking software. The contract third-party developers is the API of the Android application, the code of the Evernote program. So Evernote, I believe their API is still private, but 99% of the traffic that Evernote gets is through their API, almost all of it. There's very little that's done directly. So there are various apps that they've built, that third parties have built to integrate with Evernote that use that API. So it's not the code of the Android application isn't the API itself, it's calling those APIs to take advantage of the things of the infrastructure that Evernote has built, of the cloud infrastructure to save and retrieve notes, to save and retrieve your information, etc. So would it be an XML or JSON standard as a listener or provider? So the standards vary depending on API. Many support both XML and JSON, but generally when we're talking about the actual API, what encompasses the API, we're talking about a definition of the message format and the definition of how you're going to get it to a system that can recognize it to an endpoint. And so when you are deploying documentation for an API on our developer portal, you can put it up in a Word doc, you can type it yourself, you can use a definition file for an API, and it'll actually, if you use a file that defines the API, it'll actually let you do interactive documentation. So you can see what operations are available. You can go into an operation. You can see that it's a post or a get. You can put in some values for a real request. You can send a real request to a backend and see what sort of response it gets. So you can actually see a real world scenario and then generate sample code. So Java, Objective-C, there's I think 7 or 8 different languages that we support, where you can take sample code that actually executes that same interaction and incorporate it into your application. Okay, I think that's all the time we have. Thank you very much for joining. If you have any follow-up questions, you'll be getting a follow-up email. Feel free to email us at layer7. And hope everybody has a good rest of the week. We'll talk to you later. Thanks for joining. Bye-bye.